Alright, so now that we've dealt with our parallel lines and transversals, I'm going to show you a way that this applies to working with the three angle measures inside of a triangle. Okay, so let's just say that we write up a triangle here. And I'm going to label the three angles as A, B, and C. Okay. Now, there's a relationship between these three angles. It's very, very important as we move throughout the course. And to show you the relationship, I've got to put some parallel lines in here. I'm going to fix one of the sides of the triangle as one of my parallel lines. So let me just extend that so you can kind of see it. Okay. The other line that I'm going to draw that's parallel to this is going to go through angle C, right? So I'm not sure quite how good this drawing is. That's not too bad. They're pretty parallel. They look pretty parallel. So those are two parallel lines, okay? What's interesting is if you just focus your attention on one other side of the triangle at a time, you'll notice that the other sides are transversals. Okay, so if I just take the side that goes from angle A to angle C, it is a transversal for the two parallel lines. Okay, and I'm just going to extend that one here so you can kind of see how that works. So there's a transversal that cuts the two parallel lines, and you can ignore the other part of this. Okay. All right, so now, if you think about that, angle A here is an interior angle from the two parallel lines. Its alternate interior angle is over here below angle C. And so I'm going to write this in, and I'm going to write it in as angle A because they're essentially the same. They're the same measure, okay? Now, I know that those are the same because they're alternate interior angles. Now, if I were to consider the other side of the triangle as another transversal, okay, so the side going from angle B to angle C, so let's kind of take a look at that one. I'll extend it. You can think of it also as a transversal. Then angle B is an interior angle. I'm going to ignore this other stuff. So here I've got two parallel lines with a transversal. Angle B is an interior angle. The alternate interior angle is over here above C, okay? And we know that they're the same, they're congruent because alternate interior angles are congruent. Okay, so we put angle B up there. They're the same measure. Now what's nice about this is that we have all three angles now. Instead of having them throughout the triangle, they're all next to each other or adjacent to each other, and they all make up a straight line, right? So if I went starting here on the top right, if I swipe out angle B, then angle C, then angle A, that gives me a straight line which is 180 degrees. And so we can say that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees, okay? And so as a general rule, the sum of the three angles in a triangle will always equal 180 degrees. It doesn't matter how big the angles are or how big the sides are, it won't matter. You can make a similar argument for any type of triangle, okay? So we'd say the sum of the three angles in any triangle will be 180 degrees, okay? And the key there is the word any. It says it works for any triangle, okay?